Before we talk about all of the little details, let's first get an overview and understand what actually is cloud computing. Because Azure is a cloud computing platform. This means that Azure offers different services and we can then pay for these services and use these services. So these services can include compute, storage services, but also database and software services. Of course, later on we'll talk in much more detail about these different types of services and what are the different resources that we can use in Azure. But first of all, why do we actually need this? Of course, if we want to start a company, or maybe we already have an established company, we need to have access to different resources like a database, or we need maybe compute power, or we need to store data somewhere. And if we do have this need, we have two options. The first one would be we can either build our own data center. This would include that we have to build physically a building, we have to buy these physical servers, and we are responsible for all of the infrastructure, all of the security. We have to make sure everything is always up to date, we have to hire staff, and we are responsible for everything. And also, we have to pay a lot of upfront cost. And especially if we are a small company, this is not really so feasible, and also it is very expensive. Therefore, we have the alternative, which is that we can just rent these end products, so these services, from a cloud provider like Azure. And then we have a lot of benefits because then we only pay for what we need. And this model is just called pay as you go. And these resources like computing or storage or different types of services, we can then rent basically from Azure. Regarding the exam, it is very important to know the benefits of this type of model, this pay-as-you-go model, which we have access through with Azure. And that's why in the next lecture, we want to understand what are these exact benefits that we need to know about. In the last lecture, we've talked about the pay-as-you-go model, which relates to the Azure cloud. And this is opposing to building and investing in our own data center. And those two options are now related to the two different expenditure types. On the one side, we have capital expenditure, CapEx, and then we have operational expenditure, OpEx. And of course, building and investing in our own data center relates to capital expenditure. We have to invest high upfront cost. And operational expenditure relates to the Azure cloud model. So as I've mentioned, capital expenditure is everything where we have to invest a very high upfront cost. We have to, for example, buy our own servers. We have to invest in our own hardware, in our own infrastructure with very high upfront cost, and then we just use it and benefit from that over time. Whereas in the operational expenditure, we have no upfront cost at all. Everything that we are using, we are paying for it. So basically, for example, we are renting something, we are paying for some service that we are using immediately. But this is also beneficial from a tax standpoint, because operational expenditure can be deducted from taxes immediately as we have those expenses. While with the capital expenditure, when we, for example, buy our own data center, we have very high upfront costs, and those costs can be only deducted over time from the taxes. Examples for that, as I've already mentioned, is buying a server. So everything where we have very high upfront cost. And for the operational expenditure, of course, this is the typical example, the Azure cloud, but also, for example, in our own data center, we can have monthly costs, so operational expenditures like employees, electricity. So, for example, with the employees, we of course pay them every month, and then of course we benefit from the service, the work that these employees do, same as with the electricity. So we have no upfront cost for the electricity, but we are just paying for this as we are using it. These are the two very important expenditure models. And now that we have this distinction, let's talk about the important benefits of using the cloud. Very important, and that's what we are doing in the next lecture. Let's talk about the benefits of the cloud. First of all, we have high availability. This is referring to a continuous functioning of the services. So users should be able to access and use the services that we have provided. So this is usually measured in percentage. So the amount of time in percentage that these services can be accessed and function. And usually we have very high availability, for example, 99.9 or 99% availability. And this means in this case, we have a maximum percentage of downtime of 0.1%. So that's guaranteed by Azure SLAs, so service level agreements, depending on what resources and what services, and we'll talk about these service level agreements later on. But high availability is referring to continuous functioning of the services. Then we have scalability. This is the ability to handle increased load. So for example, if our company is growing, we are getting more and more users using the services, then we have the ability to scale up to increase the ability to handle this additional load. And we have to distinguish between vertical scalability and horizontal scalability. If we want to understand what that means, we can just think of the directions. So vertical is scaling up and horizontal in the direction of the horizon is scaling out. So what does that mean? Scaling up just means that we use the resources in the same number that we already have them, for example, a virtual machine, and just increase the power per unit. So we have, for example, more CPU per virtual machine. And scaling out then just means we add additional virtual machines in this case. This is what we refer to as scalability, handling increased load. These are the first two benefits of the cloud. Let's continue with the benefits of the cloud. We have reliability. This is referring to the ability of a system to recover from a failure and also to continue functioning. And this is achieved through global distribution. So we can deploy our resources worldwide to multiple regions, and with that we have redundancy options. So for example, data can be replicated across multiple regions, and then if one of the regions is going down in a catastrophic event, we can still maintain the functioning of these services by automatically shifting to another region where then the service will be automatically continued. And we'll talk about these regions and these replication methods much more throughout the course. But for now, reliability is referring to the ability of a system to recover from failure and continue functioning. Then we have predictability. This is referring to cost and performance. Performance means a positive user experience. Usually this is when we don't want to have the users to wait very long for applications, for data to be loaded. And this can be achieved, for example, through auto-scaling. Auto-scaling is just a so-called dynamic scalability. For example, if we have, let's say, in the evening, much more users accessing a service, then this can be automatically detected and automatically the resources and the power will be just increased so that we can handle this increased load automatically. Or also we can use, for example, load balancers that can balance the traffic across multiple systems. So like this, we can achieve automatically a high user experience. Then regarding the pricing, everything is transparent. Everything is of course published, but we have also additional tools that help us to estimate and track our cost. So we have things like pricing calculator or total cost of ownership, which we both have a look in practice later on. But we can also monitor and track our cost, and this is helping with the predictability of the cost. So this is reliability and predictability. The next benefit of the cloud is security. Here, everything is architected in a way that security can be handled either fully by Azure, or we can also, depending on the service type, we'll talk about these different service types later on, where we have sometimes also the option to handle more of this security on ourselves. So this is a big benefit, that we can outsource all of the or most of the security to Azure. And also we have updates that can be automatically applied when some of these security issues in the market are changing, and then everything can be automatically applied. And Azure is also equipped to handle, for example, so-called distributed denial of service attacks, where a lot of traffic is trying to be sent to an application, and this can be well handled by Azure. Then we have governance. This is referring to support of governance and compliance. So we have templates that can be either predefined, or we can also define them ourselves. And with those templates, the resources and services can be created automatically in such a way that corporate standards or governmental regulations can be fulfilled automatically. So these templates, for example, different ISO templates, can be just implemented, and these will then automatically ensure that all of the resources that we create that are under this template will be created in a way that matches these standards. And if some of the regulations or standards are changing, we can easily apply updates to these resources. This is security and governance. Now let's talk about manageability. Manageability is referring to the ability to manage cloud resources. And here we have two distinctions. First, we have management of the cloud. This is referring to some options that we can use to automatically manage the resources in the cloud. So we have auto-scaling, predefined templates, automatic alerts, and also monitoring and additional things that are just there to help us to manage all of the resources in the cloud without the need to manually configure everything ourselves. Then secondly, we have also management in the cloud. This is now referring to the option that we can just manage everything through the cloud. So we have the Azure portal, which we can access through a browser. We have also different options like command line interface, different APIs, and PowerShell. Later on, we'll also see the command line interface and PowerShell more in action. But for now, manageability is referring to management of the cloud and management in the cloud. In the previous lectures, we've already learned that we have the choice between having our own private data center and also using services from Azure Cloud. And following this, there are now three different cloud models. The first one is the public cloud. This is the most common one, where we are just using services from Azure Cloud. Then we have the private cloud. This is now referring to building our own data center, so we own our data center. This is completely private and owned by the company. And now the third one is a combination of public and private, which is a hybrid cloud. And now we want to dive a little bit deeper into these three different cloud models. Let's start with the public cloud. This is the most common model, and in this one, the hardware is shared with other tenants. So other companies that are using also the cloud service, and we are not owning these, but we share them with other people, basically everyone that wants to rent some services from the cloud. In this model, we have no capital expenditure, only operational expenditure according to the consumption-based pricing. And now it's important that the infrastructure is not owned by the company, but owned by the cloud provider. So we are using it, but we are not owning the infrastructure. Of course, all of the configuration options are still available. That's important. We have the same options, but we don't have absolute control over the infrastructure. So maybe if there are some super specific requirements or regulations, we don't have this absolute control because we are not owning the infrastructure. Yet all of the cloud benefits that we've learned about, they apply to the public cloud model. But now the fact that we share the hardware with other companies and we don't have absolute control over the infrastructure is the reason why there is also the private cloud. This means we build and own the private data center, or at least some infrastructure, and this is important in very special situations. For example, if there are some regulations, some legal reasons why we cannot move to the public cloud. We have very, very specific requirements, and this can only be dealt with by owning the hardware and having complete control over all of the aspects of the hardware. And of course, in this case, capital expenditure is applying. And also, of course, in this case, we as a company have also complete responsibility for all of the hardware, for all of the security. We need knowledge and upfront costs. So this can be, of course, much more complicated, but also sometimes it can be necessary. So if we need to be able to control all of the aspects of the hardware, of the security. And now, oftentimes, it can be in such situations also possible and making sense to use the hybrid cloud, because we have the downsides maybe of the private, because it's complicated, maybe it's also more expensive, and this is why maybe some critical resources we have in our private data center, and maybe some others can be just used from the public cloud. This is then a combination, of course, also from CapEx and OpEx. And an example could be we are using an app service from the cloud provider, but the data that is used in this app is, for example, stored in our on-premise SQL database. And oftentimes we move from a private cloud to a hybrid cloud model, because if we already have invested all of the resources into our private data center, we still maybe want to use it, but we can still benefit from the public cloud because we don't want to invest further in our private data center, and then we can just move from the private cloud to the hybrid cloud. But of course, also if we are using resources from the public cloud, we can still add on top of this a private cloud, and like this end up also with the hybrid cloud model. So all of the directions from public to hybrid and from private to hybrid is possible. These are the three different cloud models. And in the next lecture, we want to talk about the three different cloud service types. There are three different categories. They are very important for the exam. And that's why in the next lecture, we want to learn about these three different cloud service types. Before we talk about the different services, we want to talk about the three different categories or service types we have access to in Azure. First of all, we have infrastructure as a service, then we have platform as a service, and software as a service. This is super important for the exam, and that's why we want to dive deep enough into those different service types. Let's first start with infrastructure as a service. This is referring to renting the hardware or the underlying infrastructure. So examples of this is the most typical one, the virtual machines. We rent them, we set them up completely, we define our operating system on it, and we completely have control over everything on this virtual machine. Another one is storage and also networking, like virtual networks, load balancers, DNS, and so on. We will talk about those different services later on as well. But these are the main categories of infrastructure as a service. And with this type of service, we have most flexibility compared to all of the other types. Because now we have full control, and this is important, especially if we have some very specific requirements, for example, some custom applications that need a specific operating system, for example. And like this, we can just set up a virtual machine, we can install our operating system that we need on this virtual machine, and like this we can get our custom application working. So we have maximum control, but with that also comes, of course, highest responsibility. Always we have a pay-as-you-go model, and this is also true for infrastructure as a service. So talking about the responsibilities, this is a major difference for all of these different three types. We have a bunch of different responsibilities, and some of these responsibilities we are responsible for. So always, of course, in any of the service types, we are responsible for the devices that we are using. So what laptop we are using, that nobody has access to our phone or to our laptop. Of course, this remains always with us, with the customer, no matter what service type we are using. Same goes, of course, also for our accounts, our credentials, so nobody gets access to those. And then if we move from our on-premise data center to Azure, to the cloud provider, some of the responsibilities completely in all three service types move over to Azure. And this is, of course, the physical security of the hosts, networks, and of course of the data center. And then we have some responsibilities in the middle for which we are responsible sometimes depending on the service type that we are using. So let's have a closer look at how this behaves for the infrastructure as a service type. Of course, we mentioned for the physical security of the infrastructure, of course, the cloud provider is always responsible. So we have also the responsibility for the infrastructure as a service like this. And also we said responsibility is in all types always with the customer for these three different responsibilities. But now in the middle, what do you think? Who is responsible in the infrastructure as a service type? In this type, we are as a customer completely responsible for this. So we have, of course, complete control, for example, over our operating system, but we are also responsible for this. This is what we need to know about infrastructure as a service. And in the next lecture, we want to have now a closer look at platform as a service. Let's do this in the next lecture. In the previous lecture, we've learned about infrastructure as a service. And now we want to talk about platform as a service. In this case, in contrast to infrastructure as a service, the hardware is fully managed by Azure. So we don't need to configure and set up the hardware itself. And this is reducing the administrational efforts. So if we want to minimize the administrational efforts, like we don't want to deal with the operating system, the network controls, this can be fully managed by Azure, and like this we can use PaaS, so platform as a service types. And examples for this are different SQL databases, for example, like Cosmos DB or Azure SQL database, but also some container service, some app services where the operating system is completely managed by Azure and we are only responsible for deploying and developing the applications. So what we get from platform as a service is an environment in which we can develop and deploy applications. This is a very typical definition. So examples of that, as I mentioned, for example, SQL databases or these container services, app services. And of course, later on, we'll talk more about these specific service types as well. And now we want to also have a closer look at the responsibilities, how this behaves for platform as a service. We've already mentioned, of course, as always, the customer is again responsible for the data and the information that they are putting in. And also Azure is always responsible for the physical security of the hardware. But now in the middle, we don't have any control over the operating system. This is now completely managed by Azure. So it's fully managed. We don't have any effort with this and also no control over this. And then with the other three responsibilities, the responsibility is shared between the customer and the cloud provider. This means we both have some things that we are responsible for and some things that the cloud provider is responsible for. So in this case, we share the responsibility and everyone has their own responsibilities in those. This is platform as a service. And in the next lecture, we also want to have a closer look at the last service type, which is software as a service. Finally, let's have also a look at software as a service, what this means and what are examples of this. This is when we only use the end application. Examples for this is Microsoft Office 365 or Outlook or any other application where we are only using it, for example, Microsoft Planner. These are applications that we are usually not even installing. For example, we just have access to them, for example, through a web browser, and we do not develop this application at all. So there we don't have any effort. We only use the end product. And of course, what we still need to do is configure the solution. So for example, if we are using Outlook, we can still configure it. So for example, we set some filters, we set up the way we want this application to work, but we don't develop the application. Of course, some personal configuration is still necessary also with software as a service. And of course, the infrastructure behind that is for us completely invisible and completely irrelevant. We are only using the end product of this service type. And again, it is a pay-as-you-go model, as with all of the other service types. And in this type of service, the responsibilities, what do we think? Let's have a closer look at this, of course. The first ones are again completely with the customers, and the last ones, physical security, is with the cloud provider. And now in the middle, what do you think? How does this behave for software as a service? Now this responsibility goes completely also to the cloud provider. So we don't have anything to do with anything in this category. So Microsoft is completely responsible for this. But of course, we are still responsible for the devices, how we configure the application, what kind of data and information we are putting into this solution. But everything else, we don't have anything to do with it. These are the three different service types we have available in Azure. Let's now just quickly talk about the consumption-based model. This means we just pay for what we are actually using. So this can be priced in a few different ways. So for example, if we want to have some storage, we can just pay for the amount of storage per amount of time that we are using it. For example, 1 cent per gigabyte per month, and this can be then of course calculated by minutes. So if we only use it, for example, for half a month, we only pay, of course, half of that price. But also we have more options. We have, for example, depending on the service, like when we have a function, we pay per execution. Or if we are in a database, we also can pay per operation. So if we have a read operation or a write operation, so there are many different ways of how the consumption can be measured and then how the pricing is built. Some of the common ones are minutes, so very common per time, minutes, day, but also sometimes per execution. In a database, maybe per operation, or even in a storage, we can have operations like read and write, and also, of course, on the volume. This is applying also in the storage. So sometimes this can be even a combination of those. So for example, if you imagine you are using a database. In this case, you are paying, of course, per volume and also per operation, but also, of course, per time, because this volume is used for a specific time. So there are many factors that can play a role, but in the consumption-based models, these are the typical ones. So here it is enough to know that this can be a combination of these different factors. And of course, we know there are no upfront costs with these consumption-based models. So when we don't need the resources anymore, we can just shut them down. And then when we don't use them, for example, if we don't use and execute the functions, we are not paying anything for it. This is the consumption-based model. The opposing model to this is the fixed price model. This can be applied to save costs. For example, if we are sure that we want to use storage in the next month and we know exactly how much we need, then we can reserve this capacity, pay upfront, for example, for 1 year, and then we can just save on cost, because then it will be cheaper, because also Azure already can plan and they can make this then cheaper for us. So it's a way also for us to save on cost, to reserve the capacity. But the standard is the consumption model. And later on, we'll anyways talk a bit more about cost-saving options. For now, we have learned about the consumption-based model. Congratulations to finishing already the first module. This is a great first milestone because, as you can see, this covers a lot from the actual exam. So it's a very important module, and we also now want to quickly summarize what we've learned. We've learned cloud computing just means getting services through the internet. So data-related services that we can access through the internet. And then we have learned about benefits of the cloud. We have heard about high availability first. This means that we have a continuous functioning of services. So a high uptime of our services and a low downtime of the services. We've also learned about fault tolerance, which is the ability to respond to a failure of a component. So if one component does break, how strongly will this affect our service? Will we still be able to have the service available and working? And then once a service may have gone down, maybe a catastrophe or a disaster has happened, how quickly and how well are we able to restore the functionality after the disaster? So how quickly can we get the service back up as it was functioning before? Then we've learned about scalability. This is the ability to handle increased load. When our company grows, how well can we adjust and increase also the power behind our services? Something that's related to this is elasticity. This is now the dynamic scalability. So how quickly are we able to react to changing demands? Maybe during the evening we have a peak in demand and then we need to, for example, auto scale, so automatically and dynamically scale things up. Also remember about scalability, we have vertical scaling, which is scaling up. This means having, for example, more CPU per virtual machine, so making one virtual machine more powerful. And then we have also horizontal scaling. This means scaling out, and this means just we have more, for example, virtual machines. Then we have also agility, which is the ability to just quickly deploy and configure solutions when requirements in the market are changing. Then we can just quickly react to this. And lastly, geo-distribution. We are able to distribute our services close to where the service is needed. For example, close to where the users are. Afterwards, we've learned about CapEx versus OpEx. Capital expenditure is referring to when, for example, we build our own data center, we have a lot of high upfront cost, and we have to basically just pay upfront for our own infrastructure. And opposing to this is operational expenditure. In this case, we don't have any upfront cost. For example, we are just renting anything, we are just paying as we are using it. And this mostly applies to Azure Cloud because we just pay for the services usually when we are needing them. Then we have talked about public cloud versus private and hybrid cloud. So public cloud, we share the hardware with other tenants and we just access the services from the internet through the cloud. But then we have also the private cloud, which is usually our own data center. So this is owned by us. We actually do own the hardware, and like this, we have absolute control. So when we have some very specific, super specific requirements or regulations, this can be a choice. And also, this can be still, of course, connected to the internet. So like this, the users and the company can access the services from there, but it's just their own private data center that is owned by the company. And then a mixture of the first two is the hybrid cloud. And note that we can even start from a private cloud and still keep on using it, and then also move from there to get services from the public cloud, so we get the hybrid cloud. And also vice versa, we can start from the public cloud and decide to build our private cloud. That all works. And then we've talked about the different service types. Infrastructure as a service is the one where we have most responsibility, but also most control. Typical examples are virtual machines, storage, networking like load balancers and VNets. And then we've talked about platform as a service. Here we usually have a fully managed system which we can use to deploy and develop applications, for example, and we can just reduce the administrational efforts. And also we don't have control over the operating system. This is what we've learned as well. Typical examples, databases and app services. So these are actually most of the services are falling under platform as a service. And lastly, we've also talked about software as a service, in which we are only using the end application. Usually there's not even an installation needed. We only need to configure the solution to our needs. Examples of this is email providers, Office 365, and other applications like this. After that, we've also talked about the shared responsibility model, in which when we come from the on-premise, so from our private cloud, we have responsibility for everything. And then slowly, as we are going through the different service types, the responsibilities are shifting more towards the cloud provider. And in the last lecture, we've also talked about the consumption-based model, where we have no upfront cost and we only pay for what we are using. This was the first module already, which is a big part of the exam, so congratulations on this.